This time I've got something a little bit different to look at. These are exit signs. And the guy that sent them to me was telling me that they're failing after like 5 years of use, and they're like 70 bucks a pop to replace them. So he sent me a bunch of them so I can see what's going wrong and see what can figure out what part is failing on these signs. So let's take a look at this one and see what the problem is. I got sent a big box of LED strips for exit signs, and this is the letter from the fellow that sent it to me to take a look at. We're trying to figure out why these things are failing, and this is what he says here. It says, enclosed is a collection of LED strips that have failed for the enclosed LED style exit lights. The building I look after uses these type of exit light everywhere. These strips appear to last from 5 to 7 years, where the old standard exit light typically lasted 10 to 20 years without issue. So now from bench testing, there's a transformer that allows 120 to 347 volts in and 24 AC out. When you come to a burnt strip, if you unplug and then plug it in, they light up anywhere from 5 to 30 minutes and then die out again. So as you might notice that this is the case here. When examining these, he notices one part, a transistor is taking on more heat than the others. Not sure if that's the culprit. Says, have a look and give me your thoughts on the manufacturing of these, as each board is something like $70 Canadian. He said you can dispose of the bad LED once done and keep the exit sign if you like. So we're going to take a look at these things and see what's going on, why they're failing. We're going to take a look at these and just see what's going on with them. He sent me enough of them here, but I guess this is becoming an issue where the light strips are failing in quite high numbers, and businesses that are using these exit signs are having to run around and replace all the lights every 5 or so years, whereas the old incandescent bulbs lasted forever. So he sent me these to take a look at and see if we can figure out what the common cause is. But we'll power them up and see what's going on. Here's a completed fixture. Normally this would be mounted to the ceiling, and the exit sign would go in here, and the lights shine down the exit sign and light it up. It's got a transformer on the back, AC input, and your 24 volts or whatever the output is, because this transformer apparently can operate. If we look at here, it says purple violet is 120 up to 350 volts approved. So this transformer will take up to 350 volts AC, and of course the output voltage will be higher, and it would have a regulator on board to regulate that down. And he sent me some of the bare lights himself. Some of them have got extra wire sticking out. I'm assuming this is for battery backup. Input, input is 6 to 24 volts DC. It will be on here, and the AC 120 to 347 on the AC input. Here's one that's been removed, and we can power it up with DC power here or through a transformer, which he's supplied me with a transformer with a plug on the end. So let's just plug this transformer in, and if we plug this in here, the lights should light up, which they do. Now he's telling me that they'll light up for a while and they'll go out. So let's just watch what happens and see what happens when the lights go out. Is it a failure of a regulator? This transistor here is probably a regulator, and it seems like it's going to be getting a bit warm. So maybe what's going on here is this regulator is failing, and that is why the lights themselves are going out. It doesn't appear to be a bad LED at this point, but let's just check some voltages here and see what we can see on this board. So on the main filter capacitor, we have 8 volts coming in here on the input. In AC, because it's AC input, it's 9 volts AC. Now that's running this at 120. Obviously if it was running on 347, the input would be much higher because the transformer itself would be outputting a higher voltage. We're running at 9 volts here, AC, and rectified over here on the DC side to put a little over 8 volts. Over here on this transistor, we've got 8 volts, 4.5, and 7. This is the regulating transistor. So we're going to watch this when the lights go dim, whether this voltage changes. Don't feel any heat here. I think the probably more than likely all of the LEDs are all driven in parallel, and we have a dropping resistor for each one. You see, this is our dropping resistor. So this is our 4.5 volts, which is coming off the transistor. Where is it here? That one there. If I were to measure, if I were to put my meter into ohms mode, this is the regulating transistor, and it regulates it to 5 volts. So let's let this thing run until they fail and see if it'll go out. He says it'll run for a few minutes and then it will shut down. So let's see what happens. We'll watch and see whether that 5 volt supply is dropping. Oops. Good thing my meter has protection. So 4.51, we'll watch. We'll let it run and see what happens. See if our voltage is dropping, and is it this transistor or is it some of the other circuitry around it that's failing. If we look at the back side of the board here, there's an indication that this transistor obviously does get hot because it has charred the board. So this may be where our fault is this transistor is just overheating, and when it gets hot it's shutting down, it's failing. I know someone's going to come along and say, oh, it's Chinesium, and it's actually not Chinesium, it's actually made in Canada. So I powered up these other strips, all from DC power, running them on 12 volts, and actually they should run anywhere from 6 volts, so I'll just dial down to 6. And we're at 6 volts now. If we drop below 6, the lights will probably go out, which they are. But 6 volts all the way up to 24, I think is what it said, they will operate on. Yeah, 6 to 24 volts. So I can crank this up to 24 volts and it'll still operate. And that's for battery backup, right? You can see these ones here are not working. This one here is still going strong. This one's not working. This one here is very dim. So let's pop these ones apart and just see why these lights here are not functional. This is more of investigative to see what is going wrong with these lights that they're having to replace after a few years. Oh, this one just went out over here, you see? So we'll pop these ones apart that are failing and see what's failing in them. Is it the transistor that's going bad? That's what I'm curious. And what I'll do is I'll run the power back to 6 volts so that if I short the transistor, it won't pop all the lights. Because I'm gonna actually short the transistor and see whether the ones that are dim, see if everything comes back, and see whether that's where our fault is. It looks like it probably is. It looks like the transistor's been pretty warm on all of these. You can see the plastic is actually melting around the actual transistor itself. So I'm gonna go out on a limb and say that that's probably where our failure point is that transistor has gone bad. Pop the board out of here. And we'll just measure some voltages while I've got it apart. Get Mr. Meter in here and see what my voltages are on that regulator transistor. So we'll still have power going in here on the board here on the capacitor, which should still have 6 volts here, which well, I got 4 volts because I turned it down. But I just want to check at the transistor here and see what voltages we've got here. I got 1.6 volts, I got 4 volts there, I got 4 volts here, and if I do that, they work. This transistor has failed. See, I should have, if I turn the voltage up a bit, I'll turn it up to 6. Our base has got 5.81. We got 6.3 on the, I think that was the emitter. Collector is down at 1.7. This transistor is bad. That's what's wrong here. Okay, I just shocked it back into working. The transistor has failed. That's what's failing on these lights. And I bet you they're all the same. Let's just do the same. We'll just short the transistor here and see that that one comes back. And over here, that transistor is failing. There's where our fault is on this. The transistor is just giving up the ghost, and it's failing. This one here's working okay. This one hasn't failed yet. That one hasn't failed, but these three were bad. Now this one's decided it's going to start working again, probably because I bent it and I've kind of fixed the junction. Anyway, that's what's going on these transistors. Have failed. Why they're failing? It's more than likely just from the 24-hour operation operating as a regulator. That's why these ones aren't working. We got a bad transistor. Should just look it up and see what it is, and if I've got one, just swap it out for the hell of it and see what happens. See if it'll last. Put one that's a little higher wattage. See, this one's gone out completely now. But it's going to be that transistor. It's open. There, that one just went out. Two of them. Oh, everything went out because my lead fell off here. My power lead from my power supply just fell off. Just reconnect that. One moment. All right, now we're back. And 5 years is how old these are. They're all from May 1st, 2018. May 1st, 2018. May 1st, what is this one? No, this is March 5th, 2018. And this one here is also May 1st, or is that January 1st? Don't know whether they're, I don't know if they're going day, month, year. So it's either 3rd of May or 5th of March. It's depending on the way that they've coded it, but they're all 2018. Every last one of them. Here's what they are. They are it's a PNP transistor, but it's a high current switch. Low collector emitter saturation voltage, high current and high frequency, excellent linearity, fast switching time. And so it's just a basic PNP transistor, but it's a PNP transistor that it's a high current switch. Well, obviously not high enough current because it failed, and probably should have had a small heat sink on it for the amount of current that it's carrying. It's not carrying a lot because it's only got some LEDs on here. 16 LEDs is what it's powering up. It's not like it's getting hot. Like this one here is not hot. But you can tell it's been warm because if we look at the board, you can see where they... I mean, you gotta remember these are in operation 24 hours a day. Now, did the solder connection crack? Is that what caused the heat? I think it's just the transistor itself is just being pushed to the limit. And it's failed. That's where our problem is. One of these that I received was actually a full fixture. It fits in the box like this. It's held in place by springs that hold it in place, right? And they've even got the sign that goes in it. These are the signs, you'll know the ones, everyone's seen these. That's the sign itself. You'll see these hanging in buildings, right? And it snaps in like that. When it's got power applied, the whole sign lights up. So there's what the sign looks like when it's powered up, right? Everyone's seen these ones before? The glowing sign on every building. And they don't last very long. Not like the old ones. Anyway, they sent me a complete sign, a complete exit sign, brand new, just to take a look at and see what's going on with the other ones, but it's pretty obvious what's going on. It's going to need that transistor replaced, and replace that transistor and the lights will work. I'm now running one of the bad strips just from the transformer directly, and we'll notice on here that our voltage has gone up because there's no load. We had 8 volts on the one that was working, but we've got 15 volts now off the same transformer because there's no load to load it down. If we look on the back of the transistor here, we'll see that our base has got 14 volts on it. This is trying to turn the transistor on. Our would be, what is this? It's emitter collector. I think it's base emitter collector, maybe, or base collector emitter, BCE. 15 volts here. On the collector, we've got 2.5, and we've got like 13 volts on the base. If we were to short the emitter and the collector together, we get full lights, and the voltage drops down to 4.77 volts, which we would also find if we shorted that and measured it over here. Our voltage would also drop down here, I'm sure, as well, because we're going to load down the circuit. So ultimately what we need to fix this is to replace the transistor. Now, if it was running on 120 volts, it probably wouldn't be a problem, because the drop across all the LEDs, we watch our voltage here, it's at 15 volts, drops down to 4.8 volts, which is roughly the 5 volts it would operate at when the transistor is working. But if this were to be running on 347 volts, obviously we wouldn't just have 5 volts here, we'd have a lot more than that, and the LEDs would pop very quickly. So this is the regulator here. This is what makes this thing able to operate on the different voltages that could be supplied through the transformer without having to have any other type of regulation. What's the voltage rating on the capacitor, I wonder? It's probably like a 50 volt cap in here. What is this one rated? It's 105 degrees, so we know the cap itself isn't going to be what's gone bad. What is it rated at? 63 volts, right? This capacitor is rated at 63 volts. And the reason that they've gone with a capacitor like that is, again, the input on the transformer, this transformer can handle up to 350 volts or 347 volts for those buildings, those commercial buildings where they're using a 347 volt lighting circuit. So they don't have to run a separate lighting circuit for the exit signs. They can just run this transformer on the 347 volt or 240 or whatever their lighting circuit is. They can just put the transformer in directly. The output of this, of course, will be dependent on the input. Now, I've seen some of these exit signs. I saw one a while back. Somebody gave me a couple of them that actually had separate taps on the transformer. It had multiple wires, and you would connect one for 120, one for 208, and one for 347. It actually had 3 separate windings on the primary. These ones here have a single winding on the transformer. The output, of course, is going to vary depending on what the input is, and that's going to affect the DC voltage on the capacitor, which is required to be regulated so that the LEDs. But to fix this one, we would just have to change out this transistor. Unfortunately, I can't do that because I don't have a transistor like this. I'm going to look and see, maybe I've got a PNP that will work, but I think I probably don't have one that's going to be okay for this. I should also point out that that's why they didn't just put a 3-terminal fixed 5-volt regulator on here. It's because a fixed 5-volt regulator has a maximum input. Most of them have an input of like 21 volts maximum. And if you were running this off of a 347 volt AC supply, the output on here is going to be much higher than the maximum input that would be available for one of those regulator transistors. So they need to use a transistor that's capable of higher voltage. If we look at the transistor out of circuit, it's a PNP. Let me get my test leads untangled here. PNP, so positive on your emitter and collector and negative on the base. So the base is over here. So collector to base, we have 0.4 volts, which for silicon I would expect it to be more like about 0.7. But emitter to base, it's open, as it is emitter to collector, which of course it would be expected. Reverse polarity, we're actually still seeing some leakage in the reverse polarity between the collector and the base, you see. this transistor is shorted. Emitter to base, sorry, collector to base is shorted. And of course, emitter to collector and base to collector is open. There's the culprit on these. If I were to take this transistor, which I just removed, and just bridge it, because I'm only feeding it off the 120 volt supply, this light would work fine. But okay, that would only be valid on the lower voltage, and that's only because just the loading of the LEDs is going to bring the power supply down to the point where it's not going to be a problem. If I can get the solder to flow across there like that, then this should light up, which it does, and it'll be fine. These strips are mine, so I don't think he wants these ones back. He just wanted to kind of send me these to figure out what's going wrong with them. So now he knows what's wrong, and with all these signs that are failing in his building, if he goes out and buys a transistor for it and replaces it, he can save himself 70 bucks per fixture, because of course they don't repair these, they just sell you a whole new fixture for 70 bucks. So this is used in commercial buildings, and if you've got one of these, if you've got these signs in your commercial building and your exit signs are failing, that's the transistor right there that goes bad, and you can replace it. It is a, I'll get you a shot of this thing here. Can we see the number? 2SA1593. 2SA1593 is the number. That crosses over that one to an NTE 2527. It's the PNP version, not the 2526, which is the NPN that would have been used in like an amplifier, for example. This is our voltages: collector to base voltage 120 volts, collector to emitter voltage 100 volts, and base to emitter voltage is 6 volts. 4 amps is the continuous, and 8 amps pulse. Operating junction temperature is 150 degrees Celsius, so it can get hot. But the reason that they're using these voltages here, high voltages, is because if it was being fed on a 347 circuit, obviously the voltage would be higher. It's not going to be anywhere near 120 volts. Okay, it's not going to be. The capacitor is rated at 63, so that voltage is not going to be anywhere near there. We'll just measure what the AC voltage is off this transformer running at 120 volts. I think it's probably, he said 24. I don't think it's 24. I think it's probably 12. So let's see what it is. 12 volts. I guarantee it's going to be 12 volts. AC voltage is 12 volts. 13 volts. Okay. So 13 volts. Call it 12. Running this at 347 volts, you'd have about 35 volts AC. So your DC rectified voltage would be, probably 40, 45 or so. That's why you need to have the transistor that's got the higher voltage rating, because it could see, it could see closer to 50 volts across it, and having to drop the voltage down so that each LED is only going to be seeing 5 volts across its main junction here, like across the, not across the junction, but across the drop resistor, right? So across each junction of the LED, we're only seeing, get the meter back over here so you guys can see it. So from our negative terminal here, we've got 0 because I'm in AC voltage mode. 4.6, that's the loaded voltage for all the LEDs, but each LED is only seeing 3 volts across it. So running on 120 volts, you could easily eliminate that transistor. It's not needed because each LED is going to have its current limited by this dropping resistor, and our rail across here is 5 volts from across the capacitor here, right? And that's what that transistor on the one that was working was regulating at, was just under 5 volts. I think it was regulating at 5, but we're seeing 4.63 here, which is perfectly normal. And even on the capacitor here, our voltage has dropped down to 4.83 volts because just the loading of all the LEDs has dropped that current down. But I would think if you were running this off of a 12 volt battery, for example, that you probably would need to have this, because the reason this voltage is dropping down as low as it is here is because the current capability of the little transformer, right? If we measure the AC output from this, we're not going to see no 12 volts across here now. we're probably going to see about 9 volts because 6.6 volts because the current capability of the transformer is low and the LEDs are dropping it. So if we were to hook this up on a power supply and short out the transistor, we would see the current go way up and the LEDs themselves would probably be damaged. So get away with jumping the transistor out if you're using it on 120 volts with one of the little transformers. But if you're running it on an external, and most buildings would have external power or backup power, at least a lot of them would have backup power to keep the exit sign going in the event of a power failure. So they'd have a 12 volt battery or a 6 volt battery. 6 volt battery, no problem, but if it was a 12 volt battery and you didn't have that regulator transistor in there, then you could have a problem right there. Anyway, that's my rant on this one. Bad transistors, that's why it's going bad on them. So change out the transistor if you've got these lights that are bad. Change out the transistor, and that should get the LEDs back operational again. It's not the actual diodes themselves. Unlike the last signs that I saw, I got given a couple of the older exit signs, which look very much like these. It was actually the LEDs that went bad on them. They all failed. But this one here, regulator transistor, is the fault. Thanks for watching, and we will catch you in the next one. Bye.